Hey everybody, this is a clip from a bigger video on solving systems by using elimination. This is a clip that's going to cover some of the theory at the beginning of how and why we use elimination, as well as a couple of the look-fors to make you a little bit quicker with it. Okay, I hope it helps. Best of luck. So what you see on the screen right away, there is a system of equations, and I'm hoping that you're coming to this video with understanding what a system is, the fact that we have multiple equations. So I'm going to take the approach that we understand how to solve a system by using substitution. And that today, where it changes is we're just going to learn a new method, or maybe fine-tune a new method. So if we were walking through and using substitution, we would be calling that equation 1 and that equation 2, and probably taking equation 2 and isolating 4x. Then you could sub 2 back into equation 1 and so on and so on. When we go through that process of subbing 2 back into 1, it's important for us to know that really all we're doing now is we are getting an equation with one variable. And what you see in that last orange line, you now have an equation with one variable. You have the means to solve that. So for us to solve a system, it's important we have to get down to an equation with one variable. So if I was to twist that wording a little bit, really then what we need to do if we have equations with two variables is we need to eliminate a variable. And that's really what we did when we used substitution. We subbed into another equation to get it to one variable, therefore eliminating a variable. Well, elimination is a little more of a direct way to get there. So what I'm going to do is I'm going to erase everything that we just wrote down with the exception of calling those equation 1 and 2. That's universal. Now, my theory behind, or the theory behind, using elimination can get a little confusing, but if you hang tight, I think we're there. What you have in equation 1 is a statement that is true. Why is it true? It's because you've been told it's true. You've been given an equation that says 4x plus 2y equals 15. And so what you have then in equation 1 is a relationship between x and y, where when we multiply x by 4, multiply y by 2, and add them together, we always get 15. You've been given that. It is a statement that is true. You've also been given another statement that is true in equation 2. And since you have two true statements, then that means that you can manipulate those true statements however you wish. And as long as we don't do something mathematically incorrect, then the outcome between those two true statements will also always be true. And so what we can start to do is we can do operations between those two equations. As long as I add those two equations together, and I do it correctly, then my outcome is true. But I don't have to add them. I could subtract them. I could multiply them. I could divide them. Any operation I do between those two equations, as long as I do it correctly, then my outcome is also true. And that's the theory behind elimination. So if I was to take a look at those two equations, and my goal was to eliminate a variable, well, I'm going to just take like this, okay, I'm going to just stumble my way through approach. And how about I try taking equation 1 and adding it to equation 2? Now, I'm just going to put a little total line down here, just so we can see it. But I'm going to add those two equations together. So let's look on the left side of my equal sign. I'm going to take my 4x and I'm going to add it to my 1x. That's going to give me a 5x. I'm then going to add a positive 2y plus another 2y. That is going to give me a positive 4y. And then on the right side, I'm going to have a 15 added to 1. There is a 16. What I just built in gold there is a true statement, that 5x plus 4y must equal 16. The problem was it didn't really help me. Because notice, all I did was just build a third equation that has those same two variables. If my goal is to solve the system, then I don't want two variables. I want to eliminate one. So you can just see that by adding those two equations together, it did not help me. So let me get rid of that gold. And let's stumble instead and say, well, why don't I try to subtract them? Okay, just for some visual, I'm going to put down this total line just so we can keep everything clear. Now, let's subtract our two equations. Okay, 4x subtract an x is a 3x. Now, a 2y subtract a 2y, well, I could write this down, but I hope that we don't. If I have something and I subtract itself, then those are going to cancel out. And when they cancel out, that leaves me with 0. Hey, look at what just happened. On the left side of my equal sign, my y terms just canceled out. They eliminated. Beautiful. I actually really like that. And now, when I subtract my 15 and my 1, I get 14. Look at what I have in my equation. I have an equation with one variable, and it's actually a really simple equation to solve. What I just did was use the process of elimination. And that enabled me to create an equation in one variable. And I can solve that. So for me to now isolate for my x, I need to divide out my 3, and there we go. A much more direct approach to getting down to being able to solve an equation in one variable. Now, what you'll also notice is we're not done solving our system, so let's be clear on that. But it was a more straightforward approach to being able to find the value of the first variable. Take a look at my blue on the screen and you will see my communication. There is how I write down that I subtracted the two equations and I subtracted them in that order. Okay, well, we're about halfway there maybe. But what you're going to find is the rest of your system should pretty much be automatic. If we've worked through solving systems by substitution, our next action should be automatic, that we are going to sub x equals 14 thirds back into one of our original equations. And I'm hoping that we're going to sub it back into 2 because 2 seems to have smaller numbers. So I'm just going to wrap around up here. In equation 2 now, my x is 14 thirds. And I can now go through and solve. I can get rid of my 14 thirds, which means I need to subtract 14 thirds. That means I need a common denominator. So 1 is going to be 3 thirds, subtract 14 thirds. That is going to give me a negative 11 thirds. And when I divide out my 2, I'm going to multiply that bottom by it. And the only thing left for me to do now is state my solution. That I have an x value of 14 thirds and a y value of negative 11 sixths. And there we go. There is the act of us solving a system using elimination. Look, we even got some uglier numbers out of it with some fraction solutions. Okay, what I want to do for the rest of this video is to work our way through different scenarios using elimination. Okay, here we go. Okay, so let's take a look at the system I've given you in B. Okay, what's automatic? We need to talk about that system correctly. There is equation 1 and equation 2. Now, we are not going to rearrange those equations as if we were using substitution, but just a quick note on that substitution. If you take a look at both of those equations, you're either going to have to divide by 5 or divide by 3, divide by 4 or divide by 3. You're going to get fractions in a lot of cases. And probably for a lot of us, when we then solve our system using substitution, those fractions are going to slow us down, at the very least slow us down. So here is a big benefit to us of using elimination. Instead of trying to rearrange the equation, let's look at our two equations and try to figure out an operation we could do between both of those equations that could eliminate a variable. Well, if we took a look at adding or subtracting the two equations and we focused on our m terms, you'll notice if I add those two together, then I'm going to get 9m's. And if I subtract the two of them, then I'm going to get 1m. I would not have eliminated my variables. So I do not want to try to deal with my m's right now. But if I took a look at my m terms, there's my n terms. If I was to go through and add those two equations together, then I get 0. A 3n plus a negative 3n gives me 0. And that's what I'm looking for. I'm looking for terms that can cancel out. So I just found my way that I am going to eliminate my variable. I am going to take equation 1 and I'm going to add it to equation 2. Okay, I'll just put a total line down as a visual. And now I can do what it says in blue. I'm going to add those two equations together. So when I add my m terms together, I get 9. I add my n's together, they cancel out and give me 0, which is great. I add my constants together on the other side, and I just eliminated a variable. Beautiful. Look at my equation I have in gold. It is just in one variable. I can solve that nice and quick, and I even get something nice and neat like an integer. Okay, the rest is automatic. I can now sub my m value back into one of my originals. And I'll be honest with you, I don't know if there's much difference between those two. I might sub it in to equation 2 only because the numbers are a little smaller. So I'm going to get 4 times 3, which is a 12, minus my 3n. I can now isolate my variable, and I divide out, and there's my 4/3. Nice. Okay, finish off by stating my solution. And remember, we always state in alphabetical order. And I assume that you would be fine if you wanted to check that solution to take both of those values, sub them back into your equations, and see that we get the same thing. Okay, I want to take a moment for a second and just talk about maybe a little bit of a hint, a clue, look for, that's going to help you to skip over some of that, maybe guess and check of what operation do I do, so you can go directly to whether you should be adding or subtracting your two equations. Take a look at the system I gave you in B. We should be good to recognize that we have the 3's out in front of both ends. Really what we want is we want the same number. So when I box in those two 3n terms, that's going to be the term, the variable, that we can eliminate because they have the same coefficient. My decider then becomes, okay, well, should I add them together or subtract them in order to eliminate? And something that can really help you out. Look at the signs on the two terms. If I have one term that's a positive and one term that's a negative, I have opposite integers. And if I want to get those opposite integers to cancel out to give me a 0, then I need to add them together. So a positive value added to its opposite, the negative value, will cancel out and give me 0. So some way that people tend to think about it is if I have the different signs, then I know I'm going to add. Okay, I want to hop back and take a look at our solution from problem A. Okay, what you see on the screen right now is our solution from problem A. Now, if I zero in on the terms that have the same coefficient, this is going to tell me I can eliminate my y's right now by adding or subtracting. Both of them are the same sign. So I have a positive of something and another positive something, and I need them to cancel out. Well, the way that I can get them to cancel out is to subtract them. If I have two of the same thing, then the way I get them to get 0 is to subtract them. And you can see that that is your shortcut to subtracting between. So one quick way that people tend to look at it: if I have different signs, I know I'm adding. If I have the same sign, I know I'm subtracting. Okay, let's jump in and play around with another problem.